So good afternoon. Thank you for being here. I'm an evangelist in Amazon Web Services, and I'm now 100% focused on serverless because we think serverless is really showing us the direction in which development is going, so that you can, as a developer, be focused on the features you want to build, on the uniqueness of your business logic, and not in the underlying nuts and bolts. And I also wrote a book on building event-driven serverless application that has been translated to Chinese and Korean. And I also work with my publisher, with Manning, to create a free ebook. So the last one here is a free ebook on agile development for serverless platforms. It gives you a broad understanding of the technologies that you need to understand. So from agile, web APIs, what is serverless, and so on. So this could be a good way to start or to suggest to someone to start. And serverless is really becoming more and more important for developers. Because this is the survey that Stack Overflow just ran on more than 100,000 developers, and the top 3 most loved platforms are Linux, serverless, and AWS. Now, this is the kind of things that gives you energy when you wake up in the morning. And what is serverless? Serverless really means that you can create and build an application without thinking about the underlying infrastructure. You shouldn't focus on that. You shouldn't focus on the features. So it scales automatically. It's automatically built to be reliable, so that, for example, when you deploy a Lambda function, it's automatically replicated across multiple data centers, and you shouldn't think about that. And the core idea of serverless application is that you have event sources that can be web API calls, can be the upload of a file in an object storage, can be an update in a database, can be a stream of real-time data. And these events trigger a function that is a function you write with your familiar tools. You can use Node.js, Python, Java, and everything that runs on the JVM 8. So there's customer using Scala or Clojure, for example. C#. We actually support .NET Core 2. So we have and recently we added support to our Visual Studio plugin for F#. That is a really cool functional programming environment. And we also support Go. It has been requested a lot. There were tricks to run Go programs in Lambda. Now there's the native support. And this function have normally internet access, or you can give them private network access to your own virtual data center. And they can do whatever you want. It's your business logic. And customers built incredible things using this approach. So this is iRobot, the Roomba device, the vacuum cleaner. The first time you turn on one of the high-end models, they connect to the AWS cloud using the API gateway and Lambda function to register themselves and automatically get the provisioning of the IoT configuration and certificates that they will need for further connectivity. This is Vogue. Probably you know the Vogue brand. This is a reference that I'm pretty passionate about because it's from Italy, the country I'm originally from. So in Italy, Condé Nast built a photographic portal for the Vogue brand. It's called PhotoVogue, where photographers can propose their pictures. They can be evaluated, and then can be accepted on the actual Vogue brand. And the CTO of Condé Nast Italy told us that it was much faster to build, and it's also faster to run in production and cheaper. So all the possible benefits. And this is just to give you an idea of a completely different use case that you can do with Lambda and serverless architecture. This is Fannie Mae. That is the name for the Federal National Mortgage Association in the US. They monitor the risk of mortgage, and they need to run massive simulation on data. And they move this simulation in a serverless environment, where they run Monte Carlo simulation to evaluate the risk. And when they move this on Lambda, they could be able to scale from 0 to 1,000 function processing the data in parallel in a few seconds, and then they can scale down again in a few seconds. And their processing is 4 times faster running on a serverless environment. And what customers really like of Lambda is the pricing, because with Lambda functions, those functions that are triggered, you pay only for the hundreds of milliseconds of execution time. And there's a low cost for each request, but it's really small compared to the other cost. And there's a huge free tier where you can use it. And we have startups, for example, building their own companies and are reaching thousands or even tens of thousands of users without having costs from Lambda. And when you create a Lambda function, you can allocate some memory to the Lambda function. And the more memory you give, the more CPU and I/O capacity you get. It's basically a way that we use to partition a server. So when you give more memory, you are also increasing your cost, because the cost is linear with Lambda with the memory. But you also are probably reducing the execution time. So there's a balance there. This is a limit case. So this is where you have a function that is just doing computing. It's just computing prime numbers, so pure computation, no I/O. And if you give 128 megabytes, it takes almost 12 seconds to calculate all the prime numbers below 1 million and this does that 1,000 times. And it costs slightly more than 2 cents. If you give more memory, the time is reducing. The cost is basically always the same with very small fluctuation, but you can get the result much, much faster, like in 1.5 seconds. So think about the memory as something that you should test with your own application, and part of the cost is absorbed by the fact that the function will run faster. There are lots of different event sources, probably that can trigger functions, and those are probably the main 4 categories. You can have data stores, like an object store, like Amazon S3, databases, a stream of data, like with Amazon Cognito. You can have endpoints, like a web API through the API gateway, or an IoT device that is connected to the AWS IoT platform can trigger Lambda function, for example, or Amazon Alexa to build chatbots that can be the natural voice interface to Lambda functions. Development and management tools, so you can use Lambda function for automate your own development if you want, and event and messaging tools like SNS is a publish and subscribe framework that you can use, for example, to decouple the components of your architecture. And when you execute a function in a serverless environment, you can actually execute the function in different ways. The main 2 ways are synchronous and asynchronous invocation. Some services like the API gateway use asynchronous invocation, because if you receive an API, you trigger a function, and you need to wait for the response back to give the answer to the client. Other services like Amazon S3, for example, they don't care for the result, because in this case, you upload an image or a document. The Lambda function is triggered to process this document, but S3 has no interest in waiting for the result. So in that case, we use an asynchronous invocation. Asynchronous invocation can be more tricky from a development perspective, because in case of asynchronous invocation, if there is an error, you get back the error in the answer. But if you trigger something asynchronously, nobody's there for listening for errors. So what we do, we retry those functions that get an error 2 times, and then optionally, we can put the event that is triggering this error into a dead letter queue. Imagine it as a queue of messages where you can eventually monitor what is happening. But you as a developer must know this. We have a third way that is the stream-based approach that is similar to the asynchronous approach, but we use that for stream of data where order is important. You know, in a distributed system, order is always something that is critical to manage. So we have this third way that we use when you ever receive, for example, as an ordered stream of data from database updates. You know that if you change the order of the updates in a database, probably the result will be different. So in that case, we have this way to keep the order and make it available for you. Also, permissions with functions is really interesting, because from a security point of view, and security, in my opinion, is everybody's job now. It's not that the developer is creating something and then at the end calls someone to evaluate the security. Security is something that starts when you start building your application. So from a security point of view, there are 2 sets of permission. One is what the function can do. So this function, when it's triggered from an API call, can read from a database, write in another database, for example. And then there's the permission on who can call this function. And this is different, because you are decoupling the usage of the services from the consumer of the services. So from a security point of view, can create really interesting use cases. Probably the most common service that is used together with Lambda function is the Amazon API gateway. It's a gateway that can give a web interface to Lambda function. It can do lots of other things, such as protecting from DDoS attacks. It can help you monitor, throttle, manage API keys for your own users, create different tiers of users with different throughputs. Lots, of course, manage authentication and authorization at API level. And it actually works even with traditional architecture. In fact, lots of customers, they start using the API gateway with a traditional web application that maybe is running on AWS or even somewhere else. You just need to have network reachability. And then they can use the API gateway to decouple the consumer of the API from the implementation. Then they can peel the onion and eventually move some API calls to a serverless environment. In this way, you don't break the contract with the consumer. It's much, much easier. And when we created the API gateway, we wanted to give maximum freedom to developers. So basically, we said, OK, developers can write their own templates. We use the Apache Velocity template syntax from the Apache project to translate the HTTP payload into the event that the Lambda function is taking in input, and also to do the opposite, taking the response and transforming the response for the client. What we noticed is that all customers were doing the same templates again and again. So we proposed some time ago this default proxy integration. So this is probably the syntax that I would suggest you to use when you create an API with the API gateway and Lambda. On the top, there's the input that is basically taking all the information from an HTTP request and putting that into a JSON format. This will be the input of the Lambda function. And then the Lambda function must give back an answer that does the syntax at the bottom. When you give the HTTP status code, 200 of K, 404 is a miss. They optionally customize the headers, such as the content type, and then give the body and optionally flag the body as binary if it's a binary response. So if you use this syntax, you really don't need to go to the API gateway console. You can just enable the API gateway from the Lambda console. We also have another framework. It's called AppSync that we launched at the end of last year that is providing a GraphQL interface with real-time and offline support for both Lambda function, but also for other services such as DynamoDB. So if you are thinking of using GraphQL and you're thinking of data-driven applications where really most of the logic can be on the client, you can have a look at this tool. So normally, at this point, I create a function on the web console. But since we're developers, we know that we love to work on files. Actually, my suggestion is every time you have something complex with an infrastructure or with a serverless application where you have more than 2, 3 moving parts, more than 2, 3 functions, my approach is use the approach of infrastructure as code. So find a way to leverage the automation that cloud is providing to describe your infrastructure in a text file, what is usually called a template. In that way, you pass the template to the provider, and the provider will create the infrastructure for you. And if you update the template, the provider can update the infrastructure for you. And since the template describing the architecture is not a diagram in some PowerPoint slide, but it's in a text file, you can put that under version control together with your own source code files. And you can also apply the best practices of software development to infrastructure management, because you can get versioning, you can do small changes to get feedback, you can even apply Agile for infrastructure management. But when we created CloudFormation as our tool for infrastructure as code, it was really not designed for serverless. It was designed to manage load balancer, virtual servers, auto-scaling groups. So we realized that it was too complex to use. So I'd like to introduce you to SAM. SAM is the serverless application model. It's an open source language that we created so that everybody in the ecosystem can use and reuse the same syntax if they want. And it can help you describe serverless resource types, such as function, APIs, and tables very quickly. If you want, you can still use all the extension that CloudFormation provides. For example, this is a SAM template that creates a simple API that describes a simple API. So here we declare that we are creating a serverless function. We are saying that this function is triggered by an API. And this line here, transform, tells CloudFormation that this is not plain CloudFormation, but it's actually SAM, so it must apply the transformation. The transformation engine to transform this into CloudFormation template is now open source, so you can also have a look at it yourself. This will create not just the function, but all the underlying nuts and bolts that we need to run a Lambda function, such as the permission, the API gateway, the stage of the API gateway, and so on. And if you were to use CloudFormation directly, this would be the syntax. So now you realize why SAM is quite important for a serverless development point of view. And when you have a SAM template, you can use these 2 commands. Those are in the AWS command line interface. We also have a SAM CLI that provides even more features like local development. And these 2 lines do two things. The first one is packaging your code together with the template and uploading it on an S3 bucket. And the second line is doing the deploy. The deploy will take your code and your description of your architecture, compare with what is already there on AWS. Maybe it's the first implementation, so I need to build everything. Maybe this is an update, so I will check what I need to change, and apply the changes. So if you just put these 2 lines of code in a script that is maybe for automating your deployment, you're building continuous deployment for a serverless application. You just need to be able to add these 2 lines. But still, I think that building complex serverless architecture can be complex, because if I start to design a complex flow where triggers and events drive my logic, starting from this and creating the template can be complex. That's why I created this open source project. It's called Serverless by Design. This is a personal project. It's not an AWS official tool. And that's also open source, so everybody can work on it and use it easily. It's a way to describe graphically what you want to build, and also to think about what you want to build, so you can easily prototype. And when you're ready, you can generate the template to build it. So let's have a quick look at how this works. So this is the tool. And as I said, this is open source on GitHub. And here, for example, there are a few examples that you can use. So if I want to create a basic API, if I want to create a streaming analytics. And this is an example of an API where I have an API gateway, a Lambda function, and a DynamoDB table that I can use to persist my data from my API. This is a slightly more complex example. It's a streaming chain. So I get an API that is managed by a Lambda function. This goes through a streaming framework that can process, do anomaly detection, group data, and then stores the information in files in an S3 bucket. So all these kind of things, of course, they don't have their configuration at this level, but you can start thinking about what you want to build. So let's start from scratch and create an API, for example. So I click here, I can add a node. And first, I want to create an API gateway. This will be my API. Let's make it a little bit bigger. OK. And then I want to add a Lambda function. This Lambda function that will be triggered by the API is my backend. And then this Lambda function may, for example, read and write from a DynamoDB table. This is my table. And here I can put my structured information. DynamoDB is a NoSQL database with JSON support. Or I can add also an S3 bucket. This is an object storage. This is my bucket. And I can put my unstructured data here, such as, for example, multimedia content. Now I completed adding my nodes. I can add an edge, and I can connect the API gateway with the Lambda function. And then the Lambda function can be connected to the DynamoDB table, and the Lambda function can be connected with the S3 bucket. And as you see, the tool automatically infers what you want to build. So this is an integration of the API, and this is giving read-write permission. So this is a basic infrastructure. I can give my application a name. This is Athens app. I only support here non-compiled languages because it was easier. So I'm using Node.js, for example. I can output AWS SAM. A guy in Dubai in one day added support for the serverless framework. I didn't play too much with it, so I'm not sure how it works. And then you can also add a deployment preference. For now, let's keep it like this, and I will explain what that means shortly. And now I can click build. And those are the 2 commands that I need to use to deploy my application. This is downloaded here locally. I have my zip file. Let's open it. And let's open the template. And just before I edit this, let me save the 2 commands that I copied before. So this is the template. It's slightly more complex than the one that we saw. So basically, I'm declaring that it's a serverless application. This is my serverless function. It has read-write permission to DynamoDB and S3. If I want to remove read-write permission, I just delete the put item line. And then this is declaring that this is an API. This is the description of my table and of my bucket. And here I also have the code. the starting point for the code of my function. And this is just an empty function using the new Node.js 8 syntax. So basically, this is the handler of the function that is receiving input the event, that in case of the API gateway is those JSON payload that I was describing before. The context is telling me what is happening around the function, like it's a description of the execution environment. And this function is just returning hello world. So let's make something more complex. I have here some code that I built. And this is an idea also how to write good functions from a development perspective. So this is a simple API to say hello by name. So you give the name and you say hello Danilo or hello Patroclus. And the idea here is just to make the code good. So one suggestion that I always give to people building functions on a serverless platform is split your business logic from the event handler. The event handler is managing the integration with the API gateway, with Kinesis, with any other framework that you want to use. Your business logic is unique and must be split. Otherwise, if you need to change something, you are tying the implementation with the feature you want to build. So in this case, this is my business logic. It's a function that you give a name and you get hello by name. Then I have an handler that is taking the event from the API gateway and is building the response and is taking the input from the query string parameters and building the response and passing the name back. So all this part here is tied to the API gateway, but there's no mention of the business logic if not in the name of the function here. So I can reuse this code for any other API that I want to build. And since I splitted my business logic completely, I can also do things like this. So this part here in Node.js is checking if these two environmental variables are set. These are two environmental variables that we set in the Lambda execution environment. If they are not set, this function thinks, OK, I'm not running in Lambda. I'm running in a container or normally. And it's creating an Express app. And then it's tying my same business logic to the Express application. So this same code can run in a Lambda function, interactively on my laptop, or if I add a very basic Docker file, can become a container. So when you split business logic from the event handler, everything is much easier. And the event handler is actually just the old adapter pattern. So if you're familiar with the classical Java partner from the Gang of 4, this is the adapter pattern. OK, so let's copy this code and replace the basic code that was there with this code. So I go back to the editor. I replace the basic function, and I put this code here. Now I save. I have my YAML, so I can go here and take the two commands. So I have a bucket that I use for these deployments with a standard prefix that I use. And for the stack, let's call this Athens app. This is the name of the implementation, because you can implement a template multiple times, like a development implementation, a test implementation, a performance implementation. Each of those will be a different stack. So let me just remove here and copy these two lines. Let's go at the command line. Oops. Let's clear here. So this is under downloads, Athens app. These are my files. I now launch these two commands. So the first command is packaging everything and uploading to S3. And the second command, deploy, is now starting the deployment of this infrastructure. The first thing that you see is the change set. The change set is because it's comparing what's there with what you want to build. This is the first implementation, but if you do an update, it will create just the difference to be launched. And now we are building this. So if I go here and I go on CloudFormation, that is our infrastructure code framework, we see that Athens app is in creating progress. And here I can see all the events, because I'm creating the bucket, the DynamoDB table, the S3, also the deployment group and everything. So it takes now a few minutes to build the application and the API, so let's move on with the session. So this is an extension to what I built, and it's just to let you think about the event-driven side of serverless application, because it changes the way we think when we build applications. So the first part is the API gateway calling the Lambda function, and then the Lambda function can read and write from an object storage like S3 or a database table. Then I also connected 2 other Lambda functions to these repositories, because these repositories now are themselves a source of event. If I create a new user in my user table, that means that there is a new user. It's a business information for me. So this can trigger a Lambda function that can do all the other things that I need to do when I create a user, maybe validate the email, maybe check the fraud detection, and so on. And if I store something in my S3 bucket, such as a document or an image, I can process and index the image in a tool like Elasticsearch, for example, or DynamoDB. So this is an idea of how to think event-driven, where the business logic is really driven by the fact that something is changing and triggering new business logic. Especially the part here, it's actually a very basic implementation of what it's in a software architecture called event sourcing. Event sourcing means that you want to manage the business logic of your application based on events, and normally business events, not technical events, and you store them into a database, a time series, and then you process those business events. And this is very powerful, actually, because if you think any API call is telling you something, like there is a new user, there is a new purchase on my website, and this is a business information that is immutable, because if something happens, it's there, it's not changeable. So events are an immutable piece of information about your business. So thinking in this way and then reacting with your business logic to the events that come to your application is really a powerful way to define a software architecture. So what's next? We released Lambda in 2014, and we've seen incredible adoption. And customers start to tell us, we want a better way to control deployment in production. Because with a serverless application, deployment is very fast. You can just give a new version, and all your users will see the new version in a matter of probably a few seconds. Maybe this is good when you start, but if you want to control your deployment, if you want to check if something is wrong in production, because some bug, unfortunately, will not be discovered before production, you probably want to do things like canary deployments or linear deployments. And we introduced this into Lambda. So Lambda, from the start, had the support for version and aliases. So you can create multiple versions of a function, like version 1, version 2, version 3. And then you can create aliases that can link to a specific version. For example, the alias live is my production environment, is linked to version 5 of my function. If I update the alias from version 5 to version 6, all my configuration will immediately use version 6. This is something that has always been there with Lambda, and it's very powerful itself. But we want to give more control. So we added the possibility of adding weights. So now you can say, this is my alias live. I want still 95% of invocation to go to the old version. And I want to start having 5% of the invocation going to the new version to see if it works as I expected, from a technical and maybe even business point of view. And to do that, this is the script that we saw, the template that we saw before. You just need to add these 4 lines here, where you say that I give global configuration to my function to automatically publish any update to the function to this alias, live. Live is, you can put prod or whatever you want. And then you can choose your deployment preference. We have a set of those, and then you can customize if you want. In this case, this is a canary 10%, 10 minutes. It means that this will go to 10% of the users for 10 minutes. And then if it works, it's rolled out to all your users. You just need to add these 4 lines. You can also add hooks. Hooks are 2 Lambda functions that you can execute before and after the deployment and can monitor whatever you want. So if you have external things that you want to monitor to be sure that your deployment is working. And you can also add alarms. Alarms are actually on AWS CloudWatch alarms. And these alarms can be infrastructure alarms, like the latency of my API must not grow above 10 seconds, otherwise the deployment is broken. Or can be business metrics that you upload as custom metrics. For example, what we learned from Netflix. For Netflix, the key metric for them is the number of play per second. So the number of people clicking play button on a Netflix video. If they see that a deployment is changing with statistical significance, the number of play per second, probably they broke something in their deployment. Without having any other error, they automatically roll back and check in the logs what was happening. And this is what we do. So you can add infrastructure or business metrics here. If something fails, we roll back. Otherwise, we roll out to all your users. It's very easy to use. It's a powerful tool. We use that in Amazon a lot. Canary deployment is really probably the best way to manage your deployments in production. And this is actually integrated with a tool of ours called Cold Deploy, so you can see this also visually. So this is an example of how the deployment goes with the pre-validation step, the traffic shifting from the old to the new version, and then the post-validation at the end that can do other check and still roll back your deployment. And let's see how that works actually. So if I was slow enough, my API is now created. So Athens app is now rolled out. So if I go on the Lambda console, for example, I should see my backend function. I can search for Athens, and I see Athens, my backend function. And this function, if I look at the live alias, is tied to the API gateway. And here I get the URL that is automatically generated. You can, of course, then customize your domain if you want, but this is the default. So let's, for example, call /hello on my API endpoint. And I get wonder of the wonders, hello world. And if I just give a name as a query parameters, like my name is Danilo, I get hello Danilo. So this is a simple API, of course, but it's replicated across 3 different data centers in Ireland, or I can use, for example, Frankfurt. And it's automatically scalable from 0 to thousands of requests per second. And you can put your business logic there. But I don't want just hello Danilo. I want hello Danilo from Athens. So let's update my application with the new business logic. So here I have my edit. I add from Athens. Now I save my new file. I close to be sure that I saved. I can just run my 2 commands again. So I'm packaging my application again, uploading the new version, and now this is being deployed. Now the change set is comparing the new version, so I will not recreate the database table, the S3 bucket, because that's the same, but I will update, in this case, the code of my function. So let's go, for example, on the CloudFormation console. Let's refresh. We see that an update is in progress, and now everything is happening. And in a short few minutes, you see the code deployment has started. I have a link here. Oops, I stored the link instead of clicking. So now we go and see the actual deployment going on. If you remember, I selected a linear 10% every 1 minute. That means that every minute I deploy to 10% of the users, then to 20%, 30%, up to 100. And then I could add any monitoring. If something fails, I roll back. So if we see here, we're already at 10% of the traffic. And if I reload, we're still at 10%, but we can try. So 10% is not enough, but let's reload this API call multiple times. OK, we got one from Athens. And of course, most of the times, I just get the normal. But I can start, see, and then in 10 minutes, since I didn't add any monitoring to this deployment, this will go to all of the users. So now we are at 20% of rollout. Maybe it's faster to get from Athens. You know, I'm not very lucky now. I'm not getting Athens anymore. Maybe I'm caching something. OK, let's move on. So this is an idea of how you can create a project in a template and how to process this. So those are really the takeaways that I would like you to keep from my session. So first of all, when you create a serverless application, separate your business logic from the adapter, from the event handler. This makes all the evolution of your application easier, and also the work of your developers easier. Think event-driven. Don't put your logic all on Lambda functions or on functions that react to APIs. Think that this API change a database. For example, they create a new user, and then you can trigger all the business logic due to the creation of the new user with another event. This is really powerful. Events are immutable information about your business, so leverage this concept. Manage your infrastructure as code. Describe your infrastructure in the text file. This is true for serverless and traditional applications. We have this tool called CloudFormation. There are other open source tools like Terraform. For serverless, we created this open source framework, SAM, that is really powerful. And when your infrastructure is described in a text file, you can start applying software development tools to infrastructure management. Use safe deployment in production. Don't deploy all at once, unless you're really in an early stage of a startup, but start using canary and linear deployments. And canary deployments can also be used for a long period of time to monitor the business effect of a rollout. So if you are an e-commerce and you want to test if a feature is making your user do more business with you, you can keep a canary deployment for 24 hours and then compare like 90% of the user with the old version and 10% of the user with the new version and see what was the difference. This is very powerful. It's often called A/B testing in marketing, and it's a powerful tool for every company. We use that a lot in Amazon to test if a new feature is working as we expect or not. And then build your continuous integration and continuous deployment pipeline. I was doing a very basic example here, but if you use Java, for example, it's quite easy to run through Maven, create the build artifact, and then use the same approach with package and deploy to deploy into one or multiple stack. We have a tool that is called Code Pipeline that comes from the internal tool that we use in Amazon, where you can create an automatic deployment on commit, on GitHub, or on our internal tool Code Commit. And this deployment can automate deployment in multiple stages, like test, performance, user acceptance, and you can automate test or introduce human validation to move into the next step up to production, and then use. But if you want to use your favorite tools, those are the two lines that I showed that you need to integrate. And with this, thank you. I hope it was interesting, and I hope that there's still time for a few questions. There's anyone with a mic? No? So I think you will have to use your voice. No, sorry, I really can't hear you. So if anybody has a question, they can come here. Can I have a mic, maybe? A hand mic. Self-managed Q&A. No, yeah, but it's easier.
Does this work? Yeah, it does. So I'd like to ask you, I'd like your thoughts with respect to performance. And how does this serverless architecture compare to traditional deployments like using EC2 or ECS, Elastic, auto-scaling groups?
So the question...
If you move from that architecture to this type of architecture, Beanstalk or Lambda functions, is there anything we have to look into with respect to performance?
So the question is about performance and how that changes with this new approach. So here, the unit of computing is really the Lambda function. And when there is the execution of a function, we don't have concurrency in the environment. So you don't have to think in your code about having two users running in the same stream of code, because we will create parallel containers for concurrent executions. We can scale without limit. Each component will scale depending on the actual load. If this is an API call, the more calls, the more we will scale. If this is uploads from users to S3, we will scale accordingly. So you really don't need to think about that. You need to run your own performance test on this architecture to see if that is compliant with what you want to do. So no capacity planning, but you need to do performance validation, because the devil can be in the detail. Maybe the way you use the database inside a function is the bottleneck of your architecture. Did I answer your question? I don't know where is. Yeah. And then we can talk more. Is it open, the mic? Because we can't hear from the mic. Now it's open.
Hi. I have developed a backend for a really simple Android application in Lambda. And my experience was like, from 2-3 Lambdas, it's actually grown pretty fast to about 15 Lambda functions. And thinking like, how could I move the existing architecture I have on my job, for instance, in the big enterprise applications. I think like it will be a nightmare of supporting thousands of Lambdas, at least hundreds of Lambdas, because of like the more Lambdas we have, the more complexity of supporting some changes. For instance, in the example you shown where we have events stored in the DynamoDB, if event format changes, and I have 100, let's say 50 Lambdas supporting this change, it's a nightmare. So my personal thoughts is like, maybe Lambda is not for every application, and my question is like, what is your opinion, what is definitely Lambda is not for? Maybe you have some, I don't know, 5 points, like check if this and this and this, go with traditional architecture. Otherwise, Lambda is your choice, because Lambda gives a huge win in expenses, but there are drawbacks also.
So your question is about what are the best use cases and kind of application to use with Lambda, and also how eventually to migrate a large application to Lambda. So when we launch a new service as AWS, we have our own expectation, but then we discover new things when our customers start to build things that we never thought. So the examples that I did, like iRobot with IoT, a web application with PhotoVog, and also data processing with Fannie Mae, gives you an idea of how different you can do. So the most common use cases, and probably that's where you should start, because if you create something different, maybe at the beginning can be more difficult. So I always suggest start with something where you're comfortable with, is backends, so mobile web backends or IoT backends, is streaming data processing, where the integration with streaming frameworks like Kinesis is out of the box. We have another customer of ours is Thomson Reuters. You know Reuters, they sell information, and they have built a product where they monitor how the users are using their own products. They send a stream of data to Kinesis, and then they process this stream of data with Lambda function, and in less than 10 seconds, they have a dashboard with all the information of what the customers are doing that is updated. So this is another use cases. Chatbots, so Alexa and other chatbot frameworks are really easy to integrate with serverless functions. It's another way that I would use it. Data processing also in scenarios like MapReduce, or where you have lots of data, can be a use case. Instead of using a framework like Hadoop or Spark, you can even think about doing this. We have a prototype framework on our GitHub account, on the AWS GitHub account, that is called as a MapReduce built on Lambda, because what you can do, you can trigger thousands of functions that in parallel can process your input data. So it can be really easy to scale up and down. So backends is probably the most straightforward one, streaming data analytics and data processing when you store data and you need to process data that is stored. That's where I would like to start. But we've seen incredible things being built. Talking about the migration, 99% is probably the same problem as migrating to microservices. So you need to adopt, build the onion, and all those methodologies work. And you said if you start to have lots of functions, this can be a problem from a management point of view. From my point of view, it's not, because, for example, if I am the developer of the small developer team working on this function here, I only need to know my business logic and how this table works. I'm not interested in the other part. If I'm the team working on the Lambda function that is processing the bucket, I only need to know what's my input, what I need to do, and what are my output. So it's very easy with an event-driven architecture to decouple into small teams that can work independently. And in my perspective, complexity is not, when we talk about monolith, it's not about the size, it's about the dependencies. Because dependencies create complexity. This is complexity science, if you look for that, and slow down because one team needs to wait for another team to do something. A library update is breaking 3 microservices that depend on the same library. This is what you want to avoid. There are 2 kinds of dependencies in a software project. Organizational dependencies, so you should have small team that can work independently, and technical dependencies, when one team is waiting for another team to do something. And here you don't have, you can easily avoid both. So in my perspective, it's very, very scalable. I don't know if we still have time for questions. Otherwise, I'm happy to take any question. I'll be here until 4, 5. Thank you.